Have you ever wondered how your phone just knows a text is spam? Or how a shopping site can boil down thousands of reviews into a simple summary? Well, it's not magic. Today, we're going to pull back the curtain on the tech that makes it all happen. A really powerful tool called a convolutional neural network, or CNN, which basically teaches computers how to read our language. I mean, really think about it for a second. Your phone flags a message as junk without you even opening it. A website tells you a product is mostly positive instantly. How on earth can a machine that only gets ones and zeros make such a human-like call about language? Well, the secret all comes down to one thing: pattern recognition. At its very core, a CNN is just an expert pattern detector. We train it to spot the key phrases and the word combos that give a piece of text its real meaning, whether that's the shady language in a spam email or the glowing praise in a 5-star review. Okay, but before a machine can start finding patterns in our words, it has to get over this one massive hurdle. Computers don't speak English, or any human language for that matter. They speak in numbers. So the very first thing we have to do is translate. And this translation process has a name. It's called word embedding. It's a super clever technique that turns every single word into its own unique list of numbers. We call that a vector. Now, the really crucial part here is that these numbers aren't random at all. They're specifically designed to capture the word's meaning and how it relates to all the other words. And check this out. This is just how powerful these embeddings are. This famous example shows that if you take the number vector for king, subtract the vector for man, and then add the vector for woman, the result you get is incredibly close to the vector for queen. The machine can literally do math on concepts. That's how it learns relationships, not just definitions. It's pretty wild. So now that we've turned our words into logic and numbers, the CNN can finally get to work. Let's walk through exactly how this digital pattern detective does its job. To really see this in action, we're going to take one simple sentence and follow it through the entire process, from start to finish. All right, here's our sentence. Deep learning is powerful. Super simple, right? But it's packed with the exact kind of patterns a CNN is built to find. So the first thing that happens is we take each word and run it through that word embedding process. Instantly, our sentence isn't text anymore. It's a grid of numbers, what we call a matrix. Each row you see here represents one of the words from our sentence. This right here, this is what the CNN actually sees. Not words, just a block of numbers. The important patterns are hiding in there, and the next step is all about hunting them down. So how does it find them? It uses these things called convolution filters. The best way to think of them is like little scanning windows. They slide across our grid of numbers, and each one is looking for a very specific phrase or combination. Yeah, each filter is basically a little specialist. One filter might be on the lookout for 2-word phrases. We call those n-grams. Another one might be searching for 3-word phrases. The whole point is to identify the most meaningful chunks of the sentence. So you can imagine one filter sliding over the numbers. Let's say this one's been trained to spot important tech terms. When it passes over the vectors for deep and learning together, bam, it fires off a strong signal. It's found a meaningful pattern. And at the exact same time, you've got another filter, filter B, doing its own scan. Maybe this one is trained to look for positive words. When it slides over the numbers for is powerful, it lights up too. It's found another key pattern. Okay, so we've scanned the sentence, and now we have a bunch of these patterns that the filters have found. But which ones are the most important for figuring out what the sentence actually means? The CNN needs a way to separate the good stuff from the noise. And that's exactly what this next stage is for. The network looks at all the signals it got from all the different filters, and for each one, it picks out the single strongest hit. This whole process is called max pooling. I love this analogy. Think of it like a journalist going through their interview notes. They're not going to publish every single word, right? No, they're going to find the most powerful, most impactful quotes and put those in the headline. Max pooling does the exact same thing. It grabs only the most significant features, like deep learning and is powerful, and lets the rest go. All right, we're on the home stretch. We've turned words into numbers, we've found the key patterns, and we've picked out the most important ones. Now we're at the final step, where the network puts it all together to make a decision. These essential features, the greatest hits that we just selected with max pooling, they get fed into the final layer of the network. You can pretty much think of this layer as the judge. It takes these key pieces of evidence and comes to a conclusion. And boom, based on the combined strength of spotting deep learning and is powerful, the network makes its final call. It concludes with 95% confidence that our sentence has a positive sentiment. And just like that, the machine has read and understood the text. Now, this whole process isn't just some cool thought experiment. This is the engine running behind the scenes on so many of the apps and websites we use every single day. I mean, that whole 5-step process we just walked through, that is what's happening when your email client flags spam, when a news app categorizes articles into topics, or when an Amazon page summarizes thousands of product reviews for you. CNNs are out there, constantly detecting patterns to make sense of all the text around us. And this really shows us where CNNs just knock it out of the park. Because they can scan for all the key phrases at the same time, they are incredibly fast and super efficient. That makes them perfect for classification tasks. They're different from other models, like RNNs, which have to read word by word, making them better for things where the exact sequence is critical, like language translation. And that leaves us with one last really interesting question to think about. We've seen that CNNs are amazing pattern detectors, fantastic at picking out key phrases. But what happens when the order of the words is what really carries the meaning? The difference between dog bites man and man bites dog. Well, that's where we start to see the limits of this model, and it opens the door to a whole other universe of AI. But that's a story for another day.